Hi, welcome to Total Dino, the podcast that asks, what's your favorite dinosaur? I'm Tim, and I'm the guy that's going to talk about, hopefully, your favorite dinosaur. And if I don't talk about your favorite dinosaur this time, well then, request it, and I will talk about it at some point. So for this episode, I've got a paper that came out sort of recently, and then I've got a large topic to dive into. It's a phylogenetic group, which is just a nerdy way of saying it's a certain group of dinosaurs. But we'll get to that when we get to it. First of all, I want to do some shout-outs. I've been trying to promote my Patreon and stuff, and I realized I should probably shout out the people who have been cool enough to support me on Patreon. If you're listening to this podcast, you can thank them, as I'm about to right now. I've got 3 tiers. The Cretaceous, Jurassic, and Triassic tier. Very dinosaur appropriate, I know. So to thank my Cretaceous tier patrons, I'm going to shout out to Robin FQ, Dan West, and Garrett. Thank you guys very much for the support here on Patreon. And then I've got Jurassic tier Ryed, and to my Triassic tier bonus ducks. Thank you all very much, and to everyone who listens and subscribes on YouTube or follows the podcast portals, whatever they're called, Spotify, Apple Podcast. Just following and commenting and stuff helps, and I appreciate it. So, if anyone wants to hear more of these and motivate me to do them more often, join me at patreon.com/totaldino. And yeah, do the Patreon thing, like and subscribe, comment, do all the stuff, feed the algorithm, and I will make more dinosaur content. So, enough about that, let's talk about dinosaurs. One more thing before we get started. I have a correction from the previous episode, the Spicomelis paper. Someone kind of called me out. I kept saying that the spikes were growing straight out of the dinosaur's ribs. And that's how it appears on the bone, but to be clear, as the dinosaur grew, as the Spicomelis matured, the osteoderms would have started in its skin, so they would grow properly like osteoderms, and then they would fuse to the ribs as it got older. So, when I was saying the spikes were sticking out of the rib, or if I said growing out of the rib, what I meant was that they were actually attached to the rib when you look at the fossil, but the development of the animal isn't like they grew out of the rib. They grew as osteoderms and then fused to the rib. And Ankylosaurs are kind of known for their bones fusing together, so my apologies for saying the spikes grew out of the rib. I should have said they were sticking out of the rib, meaning that they were fused to the rib. So, apologies about that. Now, let's just dive into this paper here. This one is about the unenlagiidae. If you know what that is, good for you. You are a dinosaur nerd. If not, I will explain that in a moment. I just kind of want to point out, like the last episode I did, where it was a whole episode on one paper on the Spicomelis, I sort of wanted to do this whole episode on just this paper, but it's kind of really technical and really in the weeds with the phylogeny stuff, so I could talk about it for half an hour, but I feel like it would be really boring and kind of hard to explain. So I decided to just do this as kind of an opening news item. So I'm going to try to keep this kind of short. I feel like I can explain the general point of it in a few minutes without getting into too much technical stuff. So try to keep up with me here. So the unenlagiidae is a group of dinosaurs that basically looks like dromaeosaurs. When you think of velociraptors and stuff, that group of dinosaurs is called the dromaeosaurs. This is the group that includes velociraptors, Utahraptors, Deinonychus. The dromaeosaurs are covered in feathers. Yes, they are carnivorous. They got the sharp teeth and they got the big sickle toe claw. That's one of their most famous traits. So this paper is about unenlagiidae, which is a group of dinosaurs that is usually thought of as being within the dromaeosaurs. What they look like is pretty much like dromaeosaurs. They're covered in feathers. They do have the big sickle-shaped toe claw. They're carnivorous, of course. Probably the most notable difference is they have a longer snout, like a long, skinny snout that's usually thought of like for hunting fish in the water. I think is a pretty common theory about that. Probably I think the most popular or most well known these days is the Austroraptor. I think it became popular from Prehistoric Planet. Austroraptor is the largest known unenlagian, and if it is indeed a dromaeosaur, it's one of the largest, right up there with Utahraptor. Imperabator is another unenlagian that was made popular by Prehistoric Planet. Kind of interesting little side note here. Another recent paper just kind of placed Imperabator as an unenlagian. So when it came out on Prehistoric Planet, they didn't animate it as an unenlagian because they didn't. It was kind of just a more general dromaeosaur. There was another more detailed paper that came out, and so yeah, Imperabator is an unenlagian. The group also contains the Buitreraptor, which is a much smaller unenlagian, but similar kind of body plan. It's got the long snout, and besides the long snout, it looks like a dromaeosaur. It's got the big toe claw. Unenlagia is the genus that gives this group its name, obviously, but they all pretty much look like the same type of body plan. They look like dromaeosaurs with long snouts, basically. There's a variety of sizes and slightly different proportions, but there's also kind of another little group within the unenlagiidae, but separate from the unenlagiinae, to make it a little more confusing. Groups that end in "nae" are usually within a group that ends in "dae." So unenlagiinae is within unenlagiidae. Also within unenlagiidae is the Halscaraptoridae. So these are smaller aquatic kind of dinosaurs. They look like basically birds, kind of like geese. Imagine a goose mixed with a velociraptor. So they're kind of a weird little group, but they are closely related to the unenlagians because they are within the unenlagiids. So, to back it out a little bit more, the group of dinosaurs, of theropods that are, the group that I want to talk about here is the Paraves. So, Paraves are defined as all theropods more closely related to birds than to oviraptorosaurs. Oviraptorosaurs are the ones that look like Oviraptor, obviously. They kind of have the short parrot-like beaks. That's the Oviraptors. So Paraves is all the dinosaurs that are closer to birds than that, by definition. So what that ends up being, when you follow that rule, you get the dromaeosaurs, you get the birds, which is, there's a whole family tree of more and more derived birds that includes stuff like Archaeopteryx and a lot of the Cretaceous birds that pretty much look like birds but with teeth usually. And also the Paraves includes the Troodontids, which they look like they're kind of between dromaeosaurs and birds. They're not always classified as being between them. But dromaeosaurs, troodontids, and birds basically make up the Paraves. And within the dromaeosaurs, you'd find Velociraptor and Utahraptor, and usually the unenlagiids. Now, that brings me to this paper, which is basically saying that the unenlagiids are not within Dromaeosauridae. which is kind of a big deal. It's kind of a controversial claim. It's also kind of not that controversial. This classification has always been really nebulous. There's a lot of different takes on it. Not that it's opinion-based, but it's different studies have come up with different results. But I think usually people think of unenlagians as being dromaeosaurs. So that's what this whole paper is about. Specifically, like I said, the unenlagiids are typically thought of as being within the dromaeosaurs. But that is what this paper is is disputing. And what they found was that unenlagiids are in the avialans, which are basically the basal birds. Modern birds are aves. Avialae is kind of the larger group that includes all the Mesozoic birds. That's the easiest way to explain it, I guess. So anyway, the point is, unenlagiids are, according to this study, classified within the avialans, which means basically they are basal birds. So that's kind of crazy because they basically look like dromaeosaurs, but evolution, isn't about what they look like. It's just how they survived and evolved. It's pretty weird. Obviously, one paper doesn't change everything, but it's a pretty robust paper, and we might have to start thinking about unenlagiids as birds from now on. One step outside of the Archaeopteryx. So it goes dromaeosaurs, unenlagiids, Archaeopteryx, and then birds. That is very oversimplified. Don't quote me on that in any scientific scope. But hopefully that all made sense. It's pretty hard to explain without a visual aid. Look up the paper. Let me see. Phylogenetic Relationships of Unenlagiidae Among Paraves by Matthias J. Mata et al. So if you're familiar with unenlagiidae and dromaeosaurs and birds and all that, it's not super surprising, but it's kind of revolutionary. I don't know. I think it's interesting. Maybe you don't care. Check it out. Okay, so I want to dive into my main topic here now, which is a certain group of dinosaurs. It's a pretty big group. It encompasses about a third of all dinosaurs. That's right. I am talking about sauropods. So I'm not going to get too in-depth about any specific sauropod. I'm just going to kind of go down the family tree and give kind of a quick overview of each one. A couple episodes ago, I did the basic dinosaur, very, very basic groups of dinosaurs. So I'm going to narrow into sauropods and kind of walk down the phylogeny here. So sauropods, like birds, are saurischians. And it's a pretty well-known fact that birds have hollow bones. And just theropods, since that's how they're related. They're on the same lineage. Turns out sauropods had a lot of hollow bones too. It's called pneumatized. And the way their air sacs and their lungs work, basically they were full of air. Not like they weren't inflated like balloons, but they didn't have dense, heavy skeletons. So that's another interesting thing. So sauropods are the big, four-legged, long-necked herbivores. I think in general, if you know dinosaurs, you know what sauropods are. Picture like Brachiosaurus, Brontosaurus. They were a really successful group throughout the Mesozoic. They were herbivorous. They ate plants, and they were big, and they had long necks. I guess that's about as much as I need to break it down. I'm not trying to get too technical here. There's a lot to say about them, but So, starting with the original dinosaur, as we've talked about before, as it evolved, it split into two groups, the Ornithischia and the Saurischia. Ornithischia went off and did their own thing. That's not what we're talking about here because sauropods are saurischians. So that group split into theropods and sauropods, but actually that's not quite correct because sauropods are a more derived group within the sauropodomorphs. And in the Triassic, this is when the dinosaurs were obviously really early, very basal. So early sauropodomorphs looked a lot like the early theropods. They were bipedal. The very earliest ones might have even been carnivorous, but they were at least omnivorous because pretty early on they were evolving toward herbivory. So when I talk about sauropods, they were herbivorous. But obviously they evolved from a carnivorous ancestor, so there had to be transition there. So the Saturnaliids are a pretty weird example, or at kind of the most basal sauropodomorphs. They're technically sauropodomorphs, but I think they look a lot more like theropods. Saturnaliids is the first group. There's actually a lot of groups. I'm not going to name every little clade here, but I'm going to go through the kind of the larger ones. Just for some quick terminology here, the sauropodomorphs that are the basal early sauropodomorphs, kind of excluding sauropods, in other words, like the bipedal ones, are usually called prosauropods. This is not a phylogenetic clade because the sauropodomorphs has to include sauropods. So it's kind of that's not how phylogeny works. But just for the sake of talking about them, prosauropod means early sauropod, and that basically means the early bipedal ancestors of the more derived sauropods. What you think of as a sauropod, the four-legged, long-necked dinosaurs, their ancestors were bipedal. So we kind of call them prosauropods. I think that used to be a real scientific technical term, kind of before cladistics was really set up the way it is now. So prosauropods, not really in a real scientific term, but it is a good word because it explains what we're talking about. Anyway, so after the Saturnaliids, and then the Plateosauridae is probably the more well-known group, specifically the Plateosaurus. That was a larger, not as large as like sauropods in general, but pretty big bipedal long-necked prosauropod. I believe actually Plateosaurus was discovered a pretty long time ago. I think it's from Europe. I think that Plateosaurus is the oldest dinosaur genus name still in use. I might be wrong about that, but I think I read that somewhere. So science has known about them for a pretty long time. So they're still bipedal. A lot of these are still omnivorous. I think Plateosaurus was herbivorous. I think Mesospondylus, they might be thinking it was omnivorous. You got the Mesospondyllidae, which were bipedal and long-necked. At this point, they're growing larger. They got the sauropod and the sauropodomorphs got pretty big pretty quick. We're still in the late Triassic. The ancestral original dinosaur was really small. The theropods at the time were like Coelophysis, which were just really small. Dinosaurs weren't that big yet. But they were getting very, very big very quick. Now, I'm talking about the Triassic like it's just a quick period of time. This is about 30 million years here, so they did have time to evolve and grow. So the Mesospondyllidae were growing and doing that. So those are probably the two most well-known prosauropods. So after Mesospondylus and Plateosaurus, after that they got big and heavy and they became quadrupedal. And they were still just getting bigger and bigger. So basically at this point we are in the sauropods now. So now it's the early Jurassic. There were still bipedal prosauropods in the early Jurassic. But they didn't last a whole lot longer. So now we are looking at the big quadrupeds. So the first earliest diverging major group of the true sauropods is the Mamenchisauridae. Now, just because they diverged early doesn't mean they were small. These were pretty big. So like I said, they got pretty big pretty quick. They started out in the Jurassic, and they lived decently into the early Cretaceous. So the way phylogeny or just evolution works is just because they diverged early doesn't mean they went extinct early, So the Mamenchisaurids split off from the rest of the sauropods, but they kept living and evolving for a while, even as other derived sauropods went their separate way. So they're all still sauropods, but anyway. Mamenchisaurids lived mostly in the Jurassic, but into the Cretaceous. Mamenchisaurus is the name where it gets its name, and obviously probably the most well-known. The thing about Mamenchisaurids is they had the longest necks compared to their body proportions, and even regardless of proportions, just objectively the longest necks of the sauropods, which is saying quite a lot. Sauropods are known for having long necks, so having the longest neck is a pretty extreme situation. So Mamenchisaurus and Mamenchisaurids, I think the neck is about as long as the rest of the body and the tail combined, so half of these animals' length is in the neck. And that is just crazy. And so Mamenchisaurus grew to about 20 to 25-ish meters, which is pretty darn long, and some estimates are even up into the 30s of meters. So 30 meters is a pretty long animal, and a 15-meter neck is, I believe, not just dinosaurs, but the longest neck that has ever existed on Earth. So Mamenchisaurids were, right out of the bat, right in the Jurassic, just humongous animals with really long necks. So then moving along, so that's the earliest diverging major sauropod group of the true sauropods. Then going on down the line, you get the Diplodocoideae. These are the let's see, the Diplodocoids usually had kind of a more horizontal posture, which I'm going to get into. I want to talk about the Morrison Formation sauropods, but let's see, how do I do this? So the Morrison Formation, I'm just going to dive into it. The Morrison Formation is a big Jurassic geological formation where there's a lot of Jurassic dinosaurs buried. It takes up a big part of the western United States. It's named after Morrison, Colorado, so it's around Colorado. I think it goes up into like Montana. Don't quote me on this. I don't know exactly what states it takes up, but it's a huge area with a lot of Jurassic dinosaurs. And the reason that's relevant here is because there are a lot of Jurassic sauropods there. There were sauropods all over the world. They're not just in North America, but the Morrison Formation is in North America, and it has a really cool example of what's called niche partitioning. This is where similar animals that live in the same area, they're obviously competing for the same food. They're all herbivores, so they're all trying to eat plants. What happened was, this was an evolutionary pressure. Obviously, if they were all eating the same thing, they would start to die out, or their bodies would have to change. And so what happened was, some dinosaurs grew taller vertical necks and taller height to reach up in trees. Some of them got more horizontal necks that stick kind of straight out, and some could like go down and eat food off the ground, plants like lower shrubs and bushes and stuff. So that's how they were able to coexist without competing. Like the name implies, niche partitioning. They were partitioning out the niches. A niche is where an animal, finds its place and is able to get food and hide from predators and survive within the means that it has. So the Diplodocoideae is mostly pretty much dinosaurs that had the horizontal necks. And they were mostly in the Jurassic with a kind of interesting exception. So the Diplodocodidae includes the Diplodocidae, which includes the Diplodocus or Diplodocus, which you've probably heard of. It's really long. I think it might be one of the longest. It's not tall like the other ones. It's horizontal, so it's got a really long tail and a long neck. I think the tail is actually longer than the neck, but it's just a four-legged, long-necked sauropod. Also within the Diplodocidae is the Apatosaurinae, and this is an interesting group because it includes the Apatosaurus, which you've probably heard of, and also the Brontosaurus. Now, you may have heard Brontosaurus is not a dinosaur anymore, but there was a big study in 2015 that said Brontosaurus is its own thing. For about 100 years, Brontosaurus was basically technically not a true real dinosaur name because the specimens they had were close enough to Apatosaurus. They thought Brontosaurus was just a species within the Apatosaurus genus. But that's its own whole topic. In fact, I have a YouTube video on that. Check it out. Go find my YouTube channel, youtube.com/@TotalDino. And find the Brontosaurus video. Anyway, Brontosaurus and Apatosaurus are in the group Apatosaurinae, which is in Diplodocidae. Diplodocidae within Diplodocodidae. Also within Diplodocodidae is the Dicraeosaurids. Now, these sauropods are the ones that are known for having the shortest necks of all sauropods. So, when you have a group of dinosaurs like sauropods that are known for having the longest necks, having a group within that has the shortest necks basically means they look like they kind of had normal necks. And that's only the most extreme cases. Brachytrachelopan is imagine a sauropod with a long sauropod neck, except shorten it down to a normal neck, and it's just a sauropod head on a normal looking dinosaur neck. It's a pretty funky looking animal. Other Dicraeosaurids you may have heard of include the Bahatosaurus and Amargasaurus. These ones are the cool mohawk sauropods. Amargasaurus, I think, is more popular. It's got the tall spines coming out of its neck. Amargasaurus has the tall spines sticking backward toward its tail, and Bahatosaurus has them sticking forward. So it's like different types of mohawks. And I don't know how else to describe it. You have to look up a picture of them. And they're not quite like mohawks. They have there's two of them. Like they have two sort of sails down their backs. And I call them sails loosely. It's kind of unknown whether it was connected by like skin or muscle or if it was like a hump. That is sort of unknown, but just by looking at the skeleton, they had tall neck spines on their necks. Not all Dicraeosaurids had this, but the popular ones did, and that's kind of one of the weird, cool things about them. So the Dicraeosaurids Amargasaurus had a pretty normal length neck for a sauropod. It doesn't look as weird as Brachytrachelopan, but and in general, Dicraeosaurids weren't very big for a sauropod. Still big animals because they are sauropods, And then within the Diplodocodidae, there is the Rabachosauridae. These they're the only sauropods in this group that survived into the Cretaceous. So there were some in the Jurassic, but really they're known from mostly the early Cretaceous and into the late Cretaceous. Now this is interesting because pretty much the only sauropods in the Cretaceous were Titanosaurs, which were much more derived. So like I said earlier, as the group split apart, there's no reason they wouldn't just keep surviving as separate families. So Titanosaurs survived well into the Cretaceous, like through the Cretaceous, and it's kind of just a general, rule of thumb that there were only titanosaurs in the Cretaceous. Rabachosaurids are the exception to that rule. These were the horizontal-looking. They looked like a patasaurus, basically. Horizontal posture, and they lived in the Cretaceous. That's pretty much the interesting thing about them. So that's the Diplodocodidae. The sister group to the Diplodocodidae is the Macronaria. This is a big important group. Let's see. So the prosauropods, the bipedal two-legged early ones, are extinct by now. Mamenchosaurids are doing their own thing. Mamenchosaurids are mostly in Asia, so Mamenchosaurids are the weird long-necked ones. Diplodocoids are the horizontal ones, and Macronarians are everything else. A lot of times that's how phylogeny goes. It's this one, and everything else. So Macronaria means big nose. Macro, big, naria, nose. This is because they had sort of a bigger arch, and this is mostly they have a more boxy looking skull, like a bit like the Diplodocoids have kind of a long, skinny snout for sort of raking leaves off of the plants. Macronarians had more of a chomper of a snout, a shorter snout, more like a bulldog instead of a greyhound, if you don't want to think of it like that. So the first most basal, or the earliest group of these, is the Camarasauridae. If you are familiar with Camarasaurus, it'll probably give you a pretty good picture of the Macronarian skull. And also what you'll start to notice is that it has more of a vertical posture. Like I said earlier, Camarasaurus it's from the Morrison Formation, and so it lived alongside Brontosaurus and Apatosaurus and Diplodocus, but it was able to reach the higher trees because it had a more vertical neck. So that's pretty interesting. Also, a fun fact, Camarasaurus is the most well-known sauropod. I feel like it doesn't get enough love. It's not that popular in just popular culture, I guess. But if you dive into the specimens and the fossils, they have a lot. They know Camarasaurus really well. I think the whole skeleton is known from different fossils and stuff. I don't know the exact number, but there's I don't know if I want to say hundreds, but there's a lot of Camarasaurus fossil evidence there. So, moving on within the Macronaria, excluding Camarasauridae, the next group is the Brachiosauridae, which I think most people know what a Brachiosaurus is. Definitely known for having a vertical neck posture. It's also a Morrison Formation sauropod. So, Brachiosaurus lived with the Camarasaurus and the Brontosaurus. It was much taller. And again, since it's a Macronarian, it's kind of known for this big nose that it has, which actually was kind of more on top of its... the nose, the nasal arch in the skull is kind of more on top of its head, but... they used to think that Brachiosaurus had its nostrils on top of its head as like a snorkel, so it could stand underwater. This is another weird thing about sauropods, or about the history of science, I guess. Scientists didn't know how sauropods could hold their weight. They're so big and heavy, how could they possibly stand on land? So their prevailing theory was that they must have just stood in the water. Just sauropods were animals that just lived in the water with their forelegs, and since they had long necks, their heads could stick out so they could breathe. I mean, it makes sense if you gotta start somewhere with these scientific theories, but that's very outdated, and it's definitely not what we think anymore. Anyway, Brachiosaurus has its nasal arch. If you look at a picture of its skull, you can tell it's a Macronarian, but the current theory is that the soft tissue went down its face. It had an actual nose, with nostrils on the front of its head. If you look at a human skull, you wouldn't see our noses. Anyway, that's enough about Brachiosaurus noses. So they're still pretty basal, or early diverging Macronarians. A little more derived than the Camarasaurs, but yeah. So then you get down into, there's a bunch of little offshoots here, but basically after the brachiosaurids, you're in the titanosaurs. So titanosaurs, this big group of sauropods, I think it makes up about half of all sauropods. So half, not exactly, I don't know the numbers exactly, but if you look at sauropods as a whole, half of those are titanosaurs. And they are in the Cretaceous. And there's almost no other sauropods in the Cretaceous, except for the Rabachosaurids, which I mentioned earlier. So that's kind of the thing about them. So there's a handful of major groups that are fairly pretty well known. Colossosauria is a pretty big group of titanosaurs, which I think they're kind of, people have heard of them. I think only because it's a cool name. These dinosaurs are just named for being huge. Titanosaur, Colossosaur. So Colossosauria is a group within the Titanosauria. Within the Colossosauria, there's the Lonkosauria, which I never know if I'm saying that right. It's spelled so weird. Lonkosauria. And Rinconsauria. Their main thing is that they're huge. Actually, that's not totally true. Since there's so many titanosaurs, like I said, half of all sauropods are titanosaurs, it was a huge group and very diverse. And what that means is as they evolved, there's no reason that they had to keep getting bigger and bigger. Evolution is just survival of the fittest, or survival of, adapting to whatever your environment is. And since there's so many of them, some of them got smaller. And some of the smallest sauropods, which are still pretty big, are titanosaurs. It's sort of a misnomer at that point, but, evolution doesn't care what we name them. They just evolved to get smaller. One pretty recent discovery in the past year, maybe, was it last year? I don't know, look it up. It was Titanomachia, what I think is now the smallest sauropod. Smaller than an elephant, I believe, which is really small for a sauropod. So it was called Titanomachia. And it is a titanosaur because it's derived from the titanosaur group. Within Colossosauria, I do want to touch on this. Lonkosauria does contain the two that are always disputed as the largest dinosaur ever, the largest animals to walk the earth. And the two, in my mind, and if you Google it, this is basically what you'll find. It's Patagotitan and Argentinosaurus. As their names imply, they're both from South America. And that's actually, that's another point I'll get to. So that's what the Lonkosauria are known for, probably, is for containing Patagotitan and Argentinosaurus, because these were humongous animals, around in the 30s of meters in length, and like 80 tons. So the largest animals ever to walk the earth. And people always say that it's kind of cheating because, oh, what about the blue whale? Isn't the blue whale bigger? Yeah, but it doesn't walk. So, Argentinosaurus and sauropod, the titanosaurs, are the largest animals that ever walked the earth. Larger than any modern animal, much larger than elephants, and larger than anything before them. Something has to be the biggest, and this was it. So, Patagotitan, Argentinosaurus, those are the big guys. They are both within the Lonkosauria, which is in the Colossosauria. Also within the Colossosauria is the Rinconsauria. Then outside of the Colossosauria, but still within the Titanosauria, is the Saltosauroidea and the Saltosaurids. Now, something interesting about these guys is that they had osteoderms on their backs. At least some of them did. Osteoderms are when, like the name implies, osteo means bone, derm means skin, so bone skin. It's when there's literally bone growing in the animal's skin. Alongside their spine, just going down their back and like above their hips, just big, bony, just osteoderms. For like calcium storage or extra nutrients that the dinosaur doesn't need in its body, that it just kind of stores and carries along with it for when there's like a shortage of food or something, then it could take that out of its body, like a camel, I guess. Yeah, anyway, so these big titanosaurs had these big bony spikes on their backs, and it's pretty interesting and kind of cool looking. And that so that's pretty much all the clades within the sauropods. That's the sauropod family tree. I also wanted to talk about how in the Cretaceous there were titanosaurs, but what's interesting is in the northern hemisphere, in the northern continents, the hadrosaurs, that's like the duck-billed dinosaurs, the Parasaurolophus and Edmontosaurus, they were sort of, the hadrosaurs were sort of out-competing the sauropods, because the hadrosaurs were getting pretty big at this point, and due to a lot of environmental factors, just the way it went down is that the sauropods, which were all titanosaurs at this point, were pretty much exclusive to the southern hemisphere, which a lot of people don't really realize or don't think about, I guess. But that's why all the like the Argentinosaurus is from Argentina, the Patagotitan is from Patagonia. This is South America. So yeah, by the Cretaceous, there were only titanosaurs, and they were pretty much only in the southern hemisphere, because like I was talking about earlier, the niche partitioning. Sauropods are good at doing that with each other. I guess apparently sauropods and hadrosaurs were not good at doing that. They couldn't share, and the hadrosaurs kicked them out. So titanosaurs survived in South America and Africa, but it's a noticeable absence of sauropods in the northern hemisphere. Now there is one sauropod, one titanosaur in the latest Cretaceous, that is the Maastrichtian. This dinosaur lived at the very end of the Cretaceous, of the Mesozoic. That was a titanosaur that lived in North America. This is the Alamosaurus that I'm talking about. It's such a weird, rare thing. I think the Alamosaurus is the only titanosaur at all that we know of in the late Cretaceous that lived in North America. And obviously paleontologists can study how their relationships are by their bones and phylogenetic analysis and stuff. What they think is that Alamosaurus descended from ancestors that were in South America, so it kind of migrated up. So for whatever reason, that all the sauropods got pushed down to the southern continents, Alamosaurus then emerged and came back up. So it's not like it survived in North America from whatever ancestors in the Jurassic or whatever. It's just one offshoot that happened to come up, which is just a weird, cool example of how weird stuff happens. Yeah. Okay. So yeah, that's the Cretaceous sauropods in the southern hemisphere. But I guess I should wrap it up now. That's a pretty good explanation or a walkthrough of the phylogeny. Yeah, sauropods. So let me know what you think. Go in the comments if you're watching this on YouTube or whatever. I do have one more thing though. In a couple of the earlier on in the episodes, I asked for some voice recordings that you guys can send in. Because I wanted to let you guys tell me your favorite dinosaurs. So, that's what this is all about. I want to hear your favorite dinosaurs. So, I actually got a cool clip from a fan that is about a sauropod. And so I'm just going to go ahead and play this. It's a really short clip.
Hi, I would like an Opisthocoelicaudia podcast.
Love the energy, straight to the point. Unfortunately, whoever submitted this didn't attach a name to it, so when you go to speakpipe.com/totaldino, it would be helpful to put your name on there, let me know who you are, or if you want to stay anonymous, that's fine. So thank you to whoever sent this to me. Feel free to email me or something and let me know, or stay anonymous if you want. So yeah, Opisthocoelicaudia is a pretty interesting sauropod. It is a saltosaurid, as I mentioned in the titanosaurs, from the late Cretaceous of Mongolia. It was about 12 meters long, so not huge for a titanosaur, but, still a humongous animal. I mean, 12 meters is nothing to shake a stick at. The name Opisthocoelocadia means posterior cavity tail, and this is in reference to the shape of some of the tail vertebrae that they discovered, which they're kind of curved in a certain way. And it kind of makes it look like Opisthocoelocadia could rear up on its hind legs, which is really interesting. It would be pretty crazy to see an animal that big do something like that, but it looks like the tail, something about the tail made the paleontologists think that it could do that, so that's why they named it that. Another interesting thing about Opisthocoelocadia is that, like I said, it's a saltosaurid. And if you remember, these are the ones that a lot of them had those osteoderms, the big bony spikes on their backs. However, Opisthocoelocadia did not have those, and it was a pretty complete fossil skeleton, so they would have been able to find those theoretically. Maybe if they find more, they could figure it out. But so far, it seems like it did not have those osteoderms, so that's kind of weird for a saltosaurid, or maybe we just didn't know as much as we thought. And one more thing kind of about the osteoderms is that the Alamosaurus, which I also mentioned, is really closely related to Opisthocoelocadia, and it did have osteoderms. So the jury's still out, and there's weird stuff going on with these saltosaurid osteoderms. So, anyway, that is Opisthocoelocadia. Thank you for that request. Again, if you want to email me, tim@totaldino.com. Tell me your name if you want a shout out or whatever, but thank you for sending that in. I have one more voice clip that someone sent me. This one is also a sauropod related clip. This comes from Jess T. Saurus, who wants to talk about her favorite dinosaur, Apatosaurus. And she has lots of good reasons for that. So, without further ado, I'm going to let Jess take it away.
Hi, my name is Jess T. Saurus, and my favorite dinosaur is Apatosaurus. I have many reasons why it is, but it all started from my love of the land before time, and my favorite character of all time, Littlefoot. So, and then my family added on to that love because my mom and grandma both crocheted me long neck stuffies, one the color of Littlefoot and the other one my favorite color. So I could cuddle with them as I watched The Land Before Time, and about drove everybody crazy because they had to watch them several times a day. So, also, I was super lucky where I live. I'm close to the Jensen Quarry. So I've been able to touch and look at Jurassic animals my whole entire life. And Apatosaurus is one of those animals in that rock wall, which is really fun. So, and as a child with my dinosaur obsession that the rest of the family helped cement because I continually got long necks for my birthday. I had an army of long necks before long. So, a couple fun stories is when I was a little kid, I got a Littlefoot piggy bank from Wendy's that had Ducky on it as well. And I saved up all these pennies I collected from everybody and did, I think, pulling weeds and stuff for. And I went to the Vernal Field House, the old building, and I went in there and spilled all these pennies out just to buy this one Safari Limited Apatosaurus figure, which I named Littlefoot and packed him around everywhere I went and fed him dandelions, which I got in trouble for because I'm allergic to dandelions, but as a child, you do crazy things. And then when I went to school, I was used to playing make-believe dinosaurs, and so I was able to mimic the dinosaur noises off of Jurassic Park and The Land Before Time, and I found out real quick that other children don't do that, and they get quite scared, and I almost got kicked out of school, so... And I used to bother my grandma a lot. I think she regretted crocheting me that dinosaur because she always used to tell me, I can't stand those dinosaur noises. So she always tried to get me to play with dolls I used to put the doll clothes on the dinosaurs that just never really clicked. But, so those are a couple fun stories I know that make people laugh. So I thought that would be fun to add. And also, as I've gotten older, it's just the love of that particular sauropod. It just is amazing to me how something that huge can actually walk on this earth. It's just amazing that it could even walk, to be honest, with how huge and just magnificent these animals really were. And I just love everything about that dinosaur, and it brings me back to the good days of my childhood, and now I'm starting to learn how to draw dinosaurs, and Apatosaurus is the one I'm learning first, so of course it has to be. So anywho, that's the reason. So thank you for letting us express our nerdiness on this podcast, and I hope everyone has a great day.
Thank you, Jess, for expressing your nerdiness. I love hearing about why people love dinosaurs and about the weird stuff they did as kids. I definitely did stuff like that too. Land Before Time was one of my favorites. My parents used to take us to the library or to the video rental place, and my brothers and I would take turns choosing a movie for the week, and I would always choose Land Before Time. So I'm right there with you. And as Jess mentioned, Apatosaurus, like I said, is from the Jurassic. So right on. Cool. Thank you again, Jess. And anyone else, if you want to send something like that in, I'll put you on the podcast just like that. Just go to speakpipe.com/totaldino and just record yourself. You can tell me your favorite dinosaur, talk about it for as long as you want. Tell me your favorite dinosaur is this or that for this or that reason. There you go. So thanks, Jess. People send me in your stuff. And again, go to patreon.com/totaldino to support me, and I'll try to make more frequent episodes. You can request dinosaurs to be featured. I'm not just doing a podcast. I'm all over the internet with my paleo art and stuff like that. So tell me your favorite sauropod. Tell me your favorite non-sauropod. Tell me your favorite hadrosaur. I guess that's it. So thank you for listening to the fourth episode, the Sauropod episode of Total Dino, the podcast that asks, what's your favorite dinosaur?